All right, I'm going to talk about your next activity. It's called the Windmill Challenge. It's an alternative energy activity. Yesterday we watched a video on the different types of alternative energy, and one of those types is wind energy. And in this activity, you're going to be using the knowledge that you've acquired from working on mechanisms. So let's look over this assignment. As you know from your science class, or energy and the environment unit, a windmill converts wind energy to a useful mechanical energy. One real-world use of a windmill is to grind grain into flour. The rotary movement of the sail, turned by the wind, changes the direction of motion by 90 degrees. The equipment that you'll use for this activity will be the VEX equipment that you use to create your mechanisms. The procedure goes as follows. Using your knowledge of the mechanisms recently built in class, design and build a solution to situation A described below. Then modify your solution to solve the problems described in B. Each of the situations requires a change in direction of motion by 90 degrees, but requires a different input-output speed relationship. Each of the structures you build will need to incorporate a mechanism to change the direction of output and possibly the input-output speed relationship. Your structure must be stable, rigid, and must hold the gears in proper relationship to each other. In situation A, the output speed and torque are equal to the input speed and torque. In situation B, the output speed must be less than the input speed, but the output torque is greater. Let's look at an example. Here I have a windmill that I've created using the VEX kit. This one may not fit either of the situations. Let's analyze it. As you can see, I have the wind sail up on a tower, and I've elected to use a chain drive to transfer the power down to the mechanism. Now what I have happening is I have the output speed greater than the input speed. To meet one of our scenarios, I may need to change this larger sprocket to a smaller one. I have a smaller sprocket down here, and it's actually below a universal joint that I was using to illustrate power. So this is just one example of a mechanism that you can set up to meet the windmill challenge. However, looking at my structure, I probably need to change the gear ratios. One of the requirements, however, is that speed is transferred at 90 degrees, and this mechanism certainly meets that requirement. So again, the windmill challenge will be started after you've finished building 8 different mechanisms. Make sure that you follow the sheet that will be provided for you in class, as well as this video, to get an example of some design ideas that you will create on your own. So until next time, good luck.